Okay, welcome to class today and welcome to the geometry units. Today we're going to go through some boring stuff, some of which might be a little bit of a review, but we have to define a whole bunch of things that are going to help us create a framework and a language to use for the next two units, aka the rest of your pre-algebra career. So the very first thing that we're going to start with, first of all, I'd like everyone to have a pencil, some colored pens if you have them, and definitely a highlighter because you're going to be drawing stuff along with me, and I want you to kind of follow along to the best of your ability and draw the things and the symbols that I draw on the screen as well. So everything starts from this very abstract thing called a point. And a point, even though we represent it very often with a dot, on a piece of paper, we'll represent it with a dot. It actually has no size, no shape, and no location. I don't know what the heck just happened there. All right, so I have two dots here. I'm going to call this one point A and this one point B. And I have no idea what is going on. What is going on? Cut to go away. Am I doing something interesting? Let's see if I can get out a different pen here if it works. All right, that worked. I apologize. I have no idea what happened there. So a point is simply a specific location in space with no size or shape to it. Even though it is represented on a piece of paper with a dot, it actually has no uh, circularness to it necessarily. It is just here, a location. It is a location in space. So I'm calling that point A. Okay. If I have 2 points, then I'm going to call this one point X and this one point Y, and they are connected by all of the infinite amount of points, and yes, there are an infinite amount of points between X and Y. I have created this thing called a line segment, and I would name this line segment XY. And you draw that by actually putting the 2 points that are associated on as endpoints on the line segment and actually draw a line segment on top. You can put these little dots on the end, but you don't need to. It's a line segment. There's another way that you can name this line segment. Because the directionality is not important, you could call this either line segment XY or line segment YX. Right? So that's a line segment. That's part of a line. Segment means part of something. And what is a line? Well, a line is if one were to continue on infinitely in both directions. I'm going to draw these little arrows on this line. So highlight the definition. A straight set of connected points that extends forever in both directions. It is also named by the points that are on it. So if I had point, let's go G, and point F, I would name this thing line GF. And you actually name it by 2 points that are on it, and you draw a line on the top of it. It's not that hard, but if you see just simply, there's not words, but it says something like this, that is referring to some line in space named GF. It has point F on it, and it goes through point G. Or, because the directionality is not important, you could also name this FG as well. So it's either GF or FG. If you cut off this line at one of these points, either F or G, you've created this thing called a ray. A ray is part of a line, but it extends simply in one direction and has one endpoint. So it extends forever, but only in one direction. So let's pretend that this line was cut off at G, but it still went through point F. I would name this ray GF. And this one, because the directionality is important, it starts at G, goes through F. G is the first letter of the name because it refers to the endpoint. Very important. It's part of a line that extends in infinitely in simply one direction and has one endpoint. You can pause the video if I'm moving too fast, by the way. Now, if you put a ray together, let's draw one ray over here. Hopefully that doesn't run off your screen. Ray, we'll name it ray XA. And you have another ray stemming from point X as well. By definition, you have created this thing called an angle. So it has ray XA and ray XC. They create angle, and let's actually draw this. It's either angle angle AXC, or there's the other way to say this is angle CXA. Okay? And if you notice something special about the way that I named it, and this is very important, if you notice about something special, the same letter is in the middle depending on how I name that. That letter is called the vertex. That point is called the vertex, and that is where both of the rays meet. So it is the end point of rays that form the angle. So in this case, you would say, get my pen again, X is the endpoint. So it is the vertex. Makes sense? All right. And excuse some of this stuff if it is a review, but we do need a framework to work with going forward. Right. So there's types of angles. You could have an acute angle that is less than 90 degrees in its measurement. So if this angle was named ABC, you would say the measurement of angle ABC is less than 90 degrees, under 90 degrees. Okay? An obtuse angle, if you had obtuse angle X, Y, that's supposed to be a Y. YZ, you would say the measurement of angle XYZ is greater than 90 degrees. It is actually, by definition, it should be between 90 degrees and 180. So maybe that's something that you want to say. So an example of this obtuse angle, the example of this obtuse angle might be something like this. Looks at about 160 degrees. Okay. A right angle is exactly and precisely no less, no more than 90 degrees, and you could put this little square in it, in which case it indicates that that is a right angle. A straight angle is one that is exactly 180 degrees. Precisely and exactly 180 degrees. And yes, you cannot tell that that straight angle is any different from a line. So if you call this angle ABC, you could say that's equivalent to line BC, or let's say line AC. You cannot tell the difference between a straight angle and a straight line. A straight line also has 180 degrees associated with it. All right, some types of angles there that you might see. More types of angles. You have a complementary angles are two angles whose measures, their sum adds up to 90 degrees. Let's see if I can draw a couple complementary angles here. My tools on here. Shape pen. No, I don't want to do that. That's actually just drawn by hand. Okay. So let's pretend that we had angle NAP, angle NAP, which is probably what you guys are taking about right about now. Okay, and angle NAP, angle NAP. Measurement, the measurement of angle NAP was equal to 40 degrees. And we have this other angle, we get a different color. Angle PAR, angle par. And the measurement of angle par is equal to 50 degrees. Therefore, the sum of those two angles, if I add them together, equals 90 degrees. And I should add up to a 90-degree angle here. And mine, because I drew it by hand, looks a little sloppy. It actually looks slightly acute. But let's pretend that I drew it perfectly. Pretend to look something like that. And it still looks a little acute, but you get the point. They add up to a 90-degree angle. It's supposed to. Maybe you could do a better job than I did. Supplementary are two angles whose measures add up to 180 degrees. Two angles whose measures add up to 180 degrees. This could be in any context. We're going to look at what's called a linear pair in a second. Okay, but this could be in any context. So let's actually just draw a couple perpendicular lines here. And when they intersect, they create a 90-degree angle here, 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 and here. So if I said the angle of this one, the measurement of this angle was 90 degrees, and the measurement of this one was 90 degrees. I call this angle X, and I call this angle Y. I would say that angle X is supplementary to angle Y because they add up to 180 degrees. Two angles whose measures add up to 180 degrees is called, once again, supplementary. Highlight the definition. It is given to you. Draw that picture. You might also draw this thing called a linear pair, which looks something like this. If I had angle B here and angle C here, I could know, without knowing anything, that those two angles must be a supplementary pair because they add up to this straight line, which I know to be 180 degrees. Adjacent angles. Adjacent is just a good word that you should know regardless of whether you're in geometry or not. The word adjacent means two things that are next to each other, usually things in space that are adjacent to each other. So I would say the adjacent states to North Carolina would be ones that we share a border with. So the adjacent states, North Carolina, let me think, you've got South Carolina, you've got Virginia, you've got Tennessee, and I think all the way over in the corner, you also have Georgia that shares a border with North Carolina. You have to get out a map to see if I'm correct or not. Adjacent angles are two angles that share a common ray or a border and they share also a common vertex. That's important as well. So your property is probably adjacent to your neighbor's property because you share a border line or maybe a fence or something like that. So if you had angle ABC, I'll put B in the middle, and angle CBX, you would say that angle ABC, let's actually write the symbols here, angle ABC and angle CBX are adjacent because they share this ray down the middle, and this ray's name is BC. They share not only the vertex B, but they share ray BC as well. Adjacent. And if you have two adjacent angles that are together and they do form a straight line, they are called, and I talked about this before a couple slides ago, they are called a linear pair. So let's write what a linear pair would be. This is going to be an X and a P and a Q. And I would say angle XPQ is a linear pair with angle QPW. Angle XPQ is a linear pair with angle QPW. And how do you know? Well, if you add them all together, they form a straight angle or a straight line, and they are indeed supplementary. So suppose, and you'd have to take out a protractor, I'm just guessing on these, the measurement of this one was 110 degrees. That would mean I could know, by a little bit of logic, 180 minus 110 is equal to 70 degrees left for the remaining supplementary pair. In this case, these things are called a linear pair. Linear pair. Cool, we'll highlight it up. Bear with me here. Okay. A plane is a two-dimensional flat surface that is extending forever. So if your Chromebook screen extended forever in all directions and has two dimensions associated with it, okay, it is a flat surface that extends forever. It's called a plane. So a plane is kind of tough to draw or signify otherwise, but I'll call something like this, and I'll call it plane P, and say that is extending infinitely in all directions. It has no depth to it. Very important. It has no depth. It can intersect lines. It could have lines embedded in them. It could have points embedded in them, but it has no depth. It does not have a third dimension. So if you think about your Cartesian plane, your coordinate plane, it has an x coordinate and a y coordinate. Those are two dimensions. And dimensions are just simply ways that you can measure things. If you have an x and a y plane, you've created this thing called the coordinate plane, and we graph stuff on it. Two things that are parallel are lines or segments in a plane that will never meet each other. They never intersect one another. Okay? So we might say that line xy, and I'll draw x here, and a y up here somewhere, is parallel. Let's use the symbol here. This is an awesome symbol. Is parallel to AB. That is line AB. So I've got to put an A and a B on it. And not only can you do that, can you draw these awesome symbols when you're writing and communicating in the geometry language, you can also take a different color and draw a couple extra arrows on any lines that are parallel. And that signifies to whoever's viewing your conjecture, whoever's viewing your picture, that those lines are indeed parallel to one another. Slightly different from parallel is this word called perpendicular. You might know what this word means. Are lines or segments that in a plane that intersect precisely at right angles. Precisely at right angles. So let's actually use a couple segments here. I'll call this LC. This is segment LC intersecting with segment PQ at a right angle, and I have taken out the protractor and confirmed that that is a right angle. Therefore, you could say LC is perpendicular to PQ. And you signify perpendicular with this upside down T symbol. This upside down T. Highlighter. LC is perpendicular to PQ. Perpendicular means intersects at a right angle. Forward, onward. Hopefully you guys are keeping up. Okay. The word congruent is a word that associates itself only with geometry. And congruent means things have equal measure. They could be segments that have equal measure. For example, it has been confirmed that this segment is supposed to be an A, and that's an X. Segment AX is the same exact measurement in length. There's only one dimension that could possibly be measured here, as GQ. And if they have the same measurement, they are called congruent. And congruent is kind of like equals. It has this equal sign associated with it. I'm having a hard time drawing a straight line here. Let's get out a different pen. Kind of like an equal sign, but it has this a tilde, this squiggly on the top, right? So congruent means something slightly different than the word equals. Something slightly different than the word equals. The word equals is synonymous, as you guys know, with is. And I could say that 5 equals equals 5 because the number 5 is 5. That's where equal sign is used. That's where the equals word is used. But congruent means something slightly different, and I don't want to use equals. You would not want to say that segment AX equals segment GQ, because I don't want to say that segment AX is segment GQ. Those are two different segments, right? You don't want to say that they're equal to one another. You want to say that they are congruent. So that's why in geometry, you have this other term that has the equal sign with the squiggly thingy on top. It is called congruent. So if I say AX not equal to GQ, because they're not the same line, they're different. If two people are the same size, that doesn't mean that they are the same person, right? AX does not equal GQ, it is congruent to GQ. And it can happen with angles as well. If angle 1 is the same measurement as angle 2, and I've drawn it pretty poorly, so I'm sure that they're not, but you would say that angle 1 is congruent to angle 2. Congruent is anything that have two things that have equal measure. Okay? To bisect something sounds kind of like the word dissect, which is where you take out the knives in science class and you start cutting things up. And this kind of means that a similar thing, but it simply means to cut something in half. To take a segment or an angle and cut it into two congruent parts, aka cuts it in half. And the midpoint is simply the place where that intersection has occurred. The place where that intersection has occurred. So let's draw a couple lines here. Or let's draw a segment, not a line. But I'll call this segment LM. And LM is being bisected. That means it is divided in half by this ray that I'll call DE. And the midpoint is this point right here. We should probably name it. We'll call it W. How about W? Right? So if that point is W, W is the midpoint, and it has been confirmed that the measurement of LW and the measurement of WM are the same. Therefore, you would say that ray DE, in this case, bisects segment LM, right? Ray DE bisects segment LM. And I'm doing this stuff because when you're in geometry, it becomes its own language of its own. The way that you have to symbolize things, the way that you have to prove things using symbols to communicate what is actually going on in the conjecture. An angle bisector is simply a ray or a line that cuts an angle in half. So if you had angle LMC and it was cut in half precisely, let's say that this one was 50 degrees and this one was also 50 degrees, that means angle LMC was bisected by this ray that we'll call MG. You would say ray MG bisects angle LMC is what that symbol would be. All right. A segment bisector, we've already discussed, is a line, array, or segment that cuts a segment in half. And I think if you just go back to the first example, that should be sufficient. That ray DE in this context is the segment bisector, the thing that cuts a segment in half. A perpendicular bisector not only cuts something in half, but does so precisely at a 90-degree angle. So in this case, I'll have a segment that I'm going to name PR. And segment PR is going to be cut in half by this ray named BA. I'm just pulling these letters off of my head. There is no rhyme or reason to my choices here. And you do not have to necessarily name your Point's the same exact thing, so don't worry about that. But if ray BA bisects PR at a 90-degree angle, it is a segment perpendicular bisector. All right, so it cuts at simply at a 90-degree angle, and you can take out the protractor to confirm that that is absolutely a 90-degree angle. Okay, a transversal is this blue line here. It is simply a line that intersects multiple lines. So go ahead and draw a couple lines like this random victim here and this random victim here, and this other one that intersects the both of them. And if that happens, that thing is called a transversal. So we'll say that segment XZ is a transversal. Almost there, right? And last but not least, vertical angles occur when two lines intersect one another. You've got these two lines extending forever, minding their own business, and then they cross each other up. And when they do that, they always create four angles. Angle 1, 2, angle 3, and angle 4. And if you have two angles that are across from each other on a line's intersection, they are called vertical angles, and they are congruent to one another. So you would say, in this case, angle 1 and angle 3 are vertical. And not only that, they are congruent. So let's say, let me just give this the eyeball test. I'll say that angle 3 is 110 degrees. That means that angle 1 must also be 110 degrees. That's what congruent means. And there's one more pair of vertical angles here. Vertical angles doesn't necessarily mean straight up and down like it would in the classical sense of the word vertical. It means that they are across from each other on an intersection in this case. Angle 4 and angle 2 are also vertical. Which means that they are across from each other on the intersection as well. And spoiler alert, they are also congruent to one another. So if this one, I guess it has to be 70 degrees here. We have a linear pair formed. The across from the intersection must also be 70 degrees. All right, so I think we've, after all of that drawing and all of those symbols and all of those definitions, we've developed a framework with which we can work with for the next couple units. See you later.